Okay, I built basically this circuit here, except I didn't use a FET. I put my resistance decade box there. But all the component values are as close as I get, 10 nanofarad instead of 8. But, you know, the two resistors are the same value. And it's a TLO 72 I used for the circuit, um, you know, which you can kind of see there. So, um, you know, those are our two capacitors. These are the, you know, decoupling capacitors for the power rails. Um, one of our resistors. Um, let's see, that's a resistance decade box, which I currently have set to 0 ohms. Um, and that's the other lead from the decade box. But you know, you can kind of see, you know, my decade box is in place of this FET basically. And right now I more or less have it close to short of the ground, and it creates a nifty little oscillator. You know, it's supposed to be a filter, but it creates a nifty little oscillator. Um, and you know, I got some control of the frequency. Um, you know, if you look at it, it's you know, like 31 kilohertz, not 27 when I put 4 ohms in it, 25 with another 3 ohms, 24 with another 2 ohms, and 23 with that many ohms. And let me go back here, and you know, notice it's going peak to peak. I mean, 24 volts is the maximum swing on this because I got a 30 volt plus or minus 15 volt supply powering it. But you know, even at, you know, 10 ohms, you know, we get oscillation. 11, 12, 13, you know, 21 kilohertz down to 20 kilohertz. But and when I go to a certain level, it finally stops oscillating. So, at any rate, that's one intriguing um, aspect of this. But let's apply, you know, some stimulus over here. Okay, so you know, basically, I don't know where we're at, so let me go run a deal here. Okay, you know, with that little resistance, you know, we're getting a peak over here of about piece of crap. God, this fucking thing is so ignorant. You know, we're getting a peak over here, you know, about 18 kilohertz. So, but you can see something interesting. This is supposed to be a unity gain filter, yet, you know, we're getting like, you know, over 10 volts output on this. And again, that's with an input, you know, of, geez, 15, well, yeah, 20 ohms. So it's supposed to go down to 15 according to the book. If you look at, you know, look at the calculations there on the sheet. So at any rate, yeah, it's producing a lot of gain when it's not supposed to. You know, AV is supposed to be 1 on this thing, and I don't know really quite what the hell's going on. So, but let's look at it at, you know, the 18 kilohertz on the scope here, and see that's where I actually got it set right now on our generator. So let me hit run on it. Well, you know, so basically, yeah, it's producing like 6.7 volts output for 3.3 volts input. It's supposed to be a gain of 1. I could see it maybe being a gain of 2 given the resistor combination in there if there's something weird going on, but you know, I don't know. Like I said, you go in and out of that frequency. You see there's definitely a peak right here, you know, and it's certainly not unity gain, that's for damn sure. So, and we can go higher with it. You know, we're up to 20 volts now for a 4 volt input, so that's like a gain of 5. You know, you would think anyway. But yeah, it's a gain of 2.4. So, that's still not supposed to produce a gain that high. But at any rate, let's go back to the network analysis on this thing, because it's supposed to be a 1 kilohertz bandwidth. Again, if you read the little thing over there, it's supposed to be 1 kilohertz bandwidth, and it's supposed to vary between like 11 and 26 kilohertz or something, as far as the frequency. But again, it's going to be a little off because I didn't have exact components. Well, let's put it in run mode. First time I've ever had need to put it in run mode on network analysis. Again, we know that's the 18 kilohertz. And let's take it up an additional 20 ohms and see what happens. Okay, now the frequency, as we move away from it being a short to ground, the gain seems to diminish. And but let me back it off a little bit by 10 ohms. Okay, we're still below ground, and my total is like 30 ohms right now. Like I said, I'll see if I can set this camera on something so you don't get too seasick. But hopefully you can still see that okay. This cord has a mind of its own. Okay, but so basically, we got a 15 kilohertz, frequency there, or center frequency, and but we're below unity gain, and like I said, we're at 30 ohms. Let's see. Yeah, there's really not much. I can go below that. I guess I can lower it by another 10 ohms, though. Okay, so yeah, when I lower it, right now we're at exactly 20 ohms, just like that one time, except I'm using the 20 ohm resistor setting instead. So I can vary it, above 20 ohms, and okay, so we're at 24 now. And like I said, right here, we still got a little bit of gain, and I got it set to voltage mode. I could actually put it in gain or something, but the voltage mode stands out, really clearly, and it's showing us what we're working with. Our input voltage right now is about the same as the output voltage, but we look at it in decibels, so I exaggerated this scale, but let's see what happens. Okay, so even in decibels, sure, you see a big peak there. Okay, and a huge peak there. It's starting to really freak out. Add some more resistance back to it, about 14 ohms. So yeah, we're getting some definite gain out of it. Like I said, you look at the gain factor, wow, it's really up there. Set it back at 20 ohms. Okay, now we're back to, sub-unity gain, and let's look at 100 ohms added to it. Okay, we're definitely, below unity still. So it's just really weird that its amplification factor goes up, and I'm not sure what the mechanism is there. And if we go over here to the Google over here and look at I tried doing a Falstat simulation on this thing, and Falstat ain't the best thing to try to simulate filters with, I'll tell you that damn much. But at any rate, this is pretty much it'll take this thing a while to catch up with it, and this computer is slower than the other one. But it's still not giving me much of a clue, especially in Falstat, but it does basically simulate the action. And I got this resistor set up, to be you can use the slider function to make it variable. So that's why we got that. It's better than using those stupid pots which I've used for years, which are hard to read. Um, but it'll take this damn thing a little while to catch up, so we can just ignore that for right now. It's really not eventful, though. I mean, really, there's not much I learned from looking at Falstad at all, because it still didn't mimic most of the weird behavior as far as I could tell. It kind of seemed like it. I mean, it actually worked more like you'd kind of expect it to. But my suspicion, see here the waveforms are starting to um, come up, but they never amount to much on Falstat. Not like this. Being 10 volts, and I used a what they call a quote unquote real op amp in it, even though I could have used a 741, but boy, this thing it would really simulate slow then, I would imagine. Um, but at any rate, let's add, okay, so I just added 3K to it, so you can see the peak is, nice and well behaved, at high resistances. You can, add all the resistance here. Let me add 100K to it. So, it's like off the screen, it's so low pass at this point. Um, I'm not going down too far because this thing slows way down. I can go to 100 hertz real quick, but so you can see, what's going on. I mean, it's about, what, 700 hertz or something right now, and that's with like over 100 kiloohms on it. So, but yeah, it's basically does its job, but I don't know about its bandwidth being constant like it's supposed to. That's harder to determine, without going to decibels. I still wish they drew a 3 decibel line across here. You gotta use your fucking cursor. I guess you could use a cursor on this thing to set a 3 decibel point, but I don't think this thing has cursors. Well, it does have some cursors here, but yeah, it pops this damn big thing up. What's normal mean? Ugh, fuck it. I don't want to mess with this. But at any rate, yeah, I don't know. 3 decibel is, channel 1. It's like right about here on this. So, that's like, I don't know, 409 hertz to, I mean, it looks like it's about a kilohertz, maybe. It's 3 decibel right there. Yeah, it looks like it's about a kilohertz. So, so the bandwidth does seem relatively constant. Because it's a logarithmic scale, so let me go ahead and cut us back down. Remove the 100 kilohertz anyway, 100 kiloohms. So now we're back to 3 kiloohms. So it's we're at 1.7 kilohertz. Yeah, I don't know what possessed them to not mark the damn 3 decibel point, but let's see. So like 1.3 kilohertz to roughly. That wouldn't help though. Just thinking about going to like horizontal cursors or whatever, but anyway. Yeah, 2.3, 1.3. So it's about a 1 kilohertz bandwidth. It does seem relatively constant. I'm gonna take the 20K out now. Okay, so now we're, back over here, at 4.9 kilohertz, practically 5, and, our 4.6 to, 5.6, yeah, still about constant bandwidth. That's the only thing that is working predictably here. Take the 100 ohms out to 6 kilohertz. I guess I can go ahead and move us up to 2 kilohertz or something faster. Um, so anyway, so yeah, I mean, there's 14 kilohertz, and like I said, it's 14.5 to about 15.5. Yeah, it's about 1 kilohertz bandwidth still. So I mean, it works, and it's cool that it's tunable like that with a constant bandwidth, and for the most part, the gain is constant-ish. Um, Let me switch it back to to gain. Why not? Um, so let me start adding some resistance in here. I mean, pretty soon though it'll go off the board. But I mean, generally speaking, yeah, I mean it's right around where you'd expect, right around unity. So in terms of its gain, anyway. Now let's look at it from a voltage standpoint. Um, okay. Alright, so, we're feeding it with 4 volts, so that's our gold standard there. Now let's knock it down. Okay, still around the same voltage, still around the same voltage, still around the same voltage, diminishing a bit. Jumped way up here to 14 kilohertz. Running out of resistance though, because we're down to like 34 ohms. I'll knock it down another 4 ohms, and now we're just starting to see a peak. So that's at 30 ohms with this particular circuit. So it's curious. I'm not sure. I'm very intrigued why we start getting this crazy gain, and then eventually it breaks into oscillation. I kind of understand it breaking into oscillation. See, this is what's going on Falstad, and this was the 50 ohms in it, and you can set it pretty low here, down to 1 ohm. It breaks into oscillation too, just not high amplitude oscillation, but yeah, it takes so long to do on this computer, it's not funny. We're up to 13 ohms, 14 ohms, 16 ohms, still oscillating. Okay, now it's 22 ohms, still oscillating. Yeah, so you got to go up to like 37 ohms on Falstad to get this thing to stop oscillating. Wow, and then it just, yeah, then it really starts cooking with gas at that point. But yeah, if you look at the, like I said, the textbook, I mean, I'm very intrigued with, how you get gain. I could see if this capacitor were gone and this was a short circuit, that you might have like a gain of 2 going through these 2 resistors. But still, this is practically 0. And it must be swamping that thing out, because it is calculated in parallel down here with the input resistor, so I can see that actually up in the gain when this gets too low. So that must be something, have something to do with it. Now he was warning about one of these types of oscillator, filters becoming an oscillator if you set things wrong. Trying to find it where it is. Nope. It was up here somewhere, but right here, it's this equation. This configuration. This is a Salem key. Which we're not doing, but he talks here about how it could break out into oscillation, because you get positive feedback into this thing. But see, this is a different configuration. We're not doing that down here. We're basically using negative feedback. The positive terminal is tied to ground. So, but that's what I was kind of thinking, that as we get, closer to ground, this thing becomes an oscillator because it almost becomes a feedback path. Because see, here's the version I actually built. Just there's no component values there, but that's the configuration. 2R versus R. So, but yeah, I mean, I was thinking, because we got a path to ground, we got a signal kind of coming into it, a couple of capacitors either side of it. I mean, it's on a breadboard. I mean, there could be, a signal feeding through, to the positive terminal here, and maybe since I was able to tune it with a resistor box like I did, maybe that's a feedback path, and that can be because you can get signals feedback through ground rails, which can set all kinds of things that you wouldn't think would oscillate into oscillation. So I don't know. It's intriguing, but it would actually explain some of the gain we're getting too. That if that is a positive feedback path, that gain could be feeding back into it. So through that path. And let me see. I don't know if there's any way I can do anything about that easily, but let me look and see. Maybe there is, but let's try to get this thing to where it's got higher voltage on it. Try to reduce it that way to 20 ohms total. Okay. There's another 2 ohms. Alright, yeah, there we're getting a good heavy positive peak. So, and like I said, as I showed you, on the scope, it does happen. So let me see if there's anything I can do about the feedback path. Let me pause the video for a second. Try a little experiment here for a second. Let's go over to the scope and just run the scope. Alright, got no signal coming into it. Let's see what happens if I just, because like I said, if I decrease it, to less than 14 or less than 20 ohms or so, maybe 16, 18 ohms, it oscillates, right? Okay, I just disconnected the resistor box. Oh, and guess what? It stopped oscillating. Let me see if I can, what happens if I put this somewhere else? Like over to the actual ground without blowing the circuit up somehow. Here, I'll just hold it there. Yep, oscillation's back. So I've connected to a completely different ground point, but yep, it still oscillates. So that may not be disparate enough or what have you, but yeah, it's certainly inclined to oscillate if you don't put enough resistance. So I mean, there's some feedback path there, and since when I disconnected it, it went away. That is implicit that it's a it's probably positive feedback. Well, anyway, still, it's a strange, interesting little filter. That's why I was kind of compelled to build it. But so anyway, yeah, I don't know. Well, if anybody has any comments or suggestions on or theories, you're welcome to leave it in the comments section. So cheers.